linear programming. Okay. Before getting into linear programming, I'll give you a simple real life experience on how to convert a particular day-to-day life problem as a linear programming problem. Okay. Suppose I'm going to start a business. Okay. A furniture business wherein my items to be sold will be chairs and tables. I'm going to open a furniture shop. It will contain chairs and tables. Okay. So in the business point of view, I have certain limitations. Okay. The first thing is I have to rent out a shop, correct? To start my business. Okay. So once I rent out the shop, or if I own that shop, I have certain conditions. The first condition is the maximum number of items that I can keep in that shop. That is the space. How many items can I fill in my shop? So that is the maximum number of items that can be kept. Now my second concern would be, what is the cost of each of my item that I am purchasing from a particular wholesale dealer. Suppose I am buying the chairs for rupees X and tables for rupees Y. Okay. I am taking the chairs for rupees X and taking the tables for rupees Y from a wholesale dealer. Okay. I kept that in my shop. So my first constraint or first limit would be, what is the maximum number of chairs and tables that I can keep? So suppose if I say in that available shop I can keep 100 items. So that how much ever number of chairs, say chairs cost X rupees and tables cost Y rupees. Suppose there are A number of chairs and B number of tables that I am buying. Okay. So the first condition is the maximum number combinations of chairs and tables that I can keep in my shop would be A plus B, correct? That is the total items. So that should be less than or equal to the maximum number of items that I can keep. So the first condition is the maximum number, that is A plus B, should be less than or it can be a maximum of 100. Now the second thing is, if I have bought the chairs for rupees X and tables for rupees Y, see, when you start a business you want a profit, correct? So my next thought would be how to maximize my profit. Suppose if I am buying a chair for X and tables for Y, let it be, say, chairs for rupees 500 and tables for rupees 1500. I would have to sell these chairs and tables more than 500 for more than 500 and more than 1500. So my concern would be, what combinations of chairs and tables should I keep in my office or my shop so that I should get a maximum profit. So this is an example which we encounter in our day-to-day life, and such types of problems will come under the category called optimization problem. Okay, so optimization problem is nothing but you will be having certain aim, either to maximize your profit, or the second condition is you can minimize your cost of purchase. That is, this 500, if you bargain and if you get it for 400, that is also a sort of profit, right? And if this for 1500 rupees, each table costs 1500, and if you can get it for say 1300, there also you are making some profit. Okay, so when you start a business, our main aim is to either maximize your profit by maintaining the cost price, or by maintaining the cost of the production, or you can either minimize the cost of the production. So our aim when starting a business is either of this. Okay, so when it comes into a form of a problem, that category of problems are called optimization problem. And linear programming is a branch, or it's a sub of optimization problems.